All right, let's get this started. Hi, everyone, and welcome. Welcome to today's meetup. My name is Dalia, and I'm from Elastic's community team. Today, we're here to hear from James. He's a solution architect from Elastic, and he's going to talk to us about Elastic security and the foundation of the modern security teams. Let's take all of the questions in the end. And that's it for me. James, take it from here, please.
Sure. Thank you, Dalia, for the great intro. Hi, everyone. Good evening, good morning, afternoon. I know it's morning for some of you because some of you are from the States. So very flattering to see people join at that time. And I know people are going to watch the recording after as well. So my name is James. As Dalia said, I'm on the solutions architecture team at Elastic, specializing in security. So hopefully, I should know what I'm talking about. Been with Elastic just over 2 years, about 2 years and 4 months, and but a long-time user of the stack, so about 8 years now. And my background is entirely security operations. So, excuse me. And what we're going to talk about today is, everything we've been working on from a security side. I'm going to go through quite a few different demos. We're going to walk through like a real malware sample and that sort of stuff. And maybe if we have time, look at a sneak peek about what's to come. So we're a small group, so please do ask questions as they come along. Use the Q&A, and then at the end we can probably answer some stuff live as well. Okay, let's switch slide. Just a really quick statement. I always have to show this. Being a public company, I may be making some forward statements, so this keeps me safe. So very important. Just be aware that everything is subject to change as I talk about it, of course, especially stuff which isn't out yet. All right, so very quick introduction to Elastic for those of you who might be not too familiar with what we do and how we came to be. I always do this on our meetups and talks and webinars. Just I don't like making any assumptions really. So Elastic is a search company. A lot of you probably use Elastic today without even knowing. So if you go to Wikipedia, if you go to Netflix, if you use Uber, Lyft, any of those popular applications, those are all powered, at least their search, using Elasticsearch. So in Wikipedia, from the first keystroke you type, that's an Elasticsearch query. And search is at the core of everything we do. How did we end up being, offering a security product? So we're going to get to that. But what I always like to say is, when we're doing security analytics, it's all about being able to have an urgent conversation with your data, and that's the foundation of being able to do that is search. And we started focusing on sort of three main pillars as a company. So, and if we think about an enterprise or an organization, there's three main things everyone needs to do. You need to search. So if we think about like enterprise search, so being able to search across things like, your Gmail and Dropbox and Google Drive and wikis and all that stuff. It's like having a centralized place for search. Observability, really important. So being able to keep track of your infrastructure logs, metrics, application performance monitoring, uptime, all that good stuff. And at the same time that you're observing, why not protect? And this is all powered by the same Elastic stack, which we're going to be describing in just a second. And you can see here on this slide, I have those three solutions that I just mentioned. So we are a stack technology, but now we start providing out-of-the-box solutions to help our users more. So whereas before we used to focus on being just a stack that people can build on, the past couple of years, we've been focusing on these solutions. So enterprise search again, observability, and security, all equally important for us, of course. Okay, just want to make sure everyone can hear me because Zoom just told me it can't hear me. So I just want to make sure everything's okay. Loud and clear, thanks, Ivan. Excellent. So let's talk a bit about the stack now. So, we've heard, or hopefully you've heard of things like the Elk stack or Elastic stack. Just gonna quickly run through those components. So at the core of everything, there is Elasticsearch. So Elasticsearch is essentially a very highly scalable distributed data store. So you have a ton of data, chuck it into Elasticsearch to use it for several different things. It was designed to be very easy to integrate on top of one. Of course, open source. And again, it's meant to be run as a cluster. So you should never have what we say a single node of Elasticsearch unless you're developing or testing. It was designed to work in a horizontally scalable fashion. So you need more compute, you need more power, you need more storage. Add a node to the cluster, Elasticsearch takes care of all the hard work for you. Now, in a security sense, of course, we have a ton of data to work with, right? But we can't just put it somewhere. We need to be able to use it. And this is where the other components of the stack come in. So we have Kibana, which is our visual layer. So once I have a ton of data inside of Elasticsearch, Kibana is where, I'd say most analysts, security analysts are going to live. So Kibana these days has evolved to not only being a way to visualize the data I have in Elasticsearch, but you can now monitor and manage the entire stack, including now, as of the latest version, 7.9, setting your endpoint policies. So even up to that level, you can do all of that through Kibana now, creating detection rules, deploying new rules. So this is all happening there. We also, of course, need a way to bring data in. How do you bring data into Elasticsearch? So there's been traditionally two main ways, which are using beats and or Logstash. Beats are very lightweight data shippers. So traditionally, you'd get a beat or a couple of beats, depending on the data you want to collect, install them on a laptop, a server, Docker container, VM, whatever you can think of, enable a module. So let's say I want to bring in Windows event logs, we have a beat for that, enable the security module, PowerShell, sysmon, it sends the data straight to Elasticsearch, takes care of all the hard work for you. Beats can use something like a message broker or a log buffer. So if you think things like Kafka or even Logstash itself, if you don't want to have a connection straight into Elasticsearch, which is a very valid concern, especially for more air-gapped networks and that sort of stuff, Beats can do that. We'll be talking about Beats today to some extent, but we're also talking about mainly the new Elastic Agent, which now has endpoint security bundled in, which is sort of where we're headed towards. We want agent to be the default way people consume data. It would make more sense when you see it, but agent works on the concept of an integration rather than you having to deploy a handful of different beats. You say, I want to run X, Y, and Z on a machine, pick your integrations, build a policy, distribute it, and you're good to go. Now, Logstash, on the other hand, Logstash actually came first. This is where the ELK stack comes in, ELK. So Logstash is more of a server-side component. So you can set up a Logstash server. You can stream data to it. You can look up relational databases with it. You can bring in data from Twitter, have it receive SNMP requests, pretty much anything you can think of. It's more or less the Swiss Army knife of data ingestion and also data manipulation, because you can pretty much transform the data in any way, shape, or fashion with Logstash. Super powerful stuff. You may be seeing this and wondering, like, what made the change from ELK to the Elastic Stack after the introduction of Beats? Belk doesn't sound too great, or ELK-B or BELK. You can call it whatever you want, but we decided to call it the Elastic Stack to simplify things. So that's the stack itself, but how do you run it? So there's multiple different ways. So the easiest way, most straightforward, go to Elastic Cloud, which is our SaaS service, click a button, you have a cluster, drag a slider across the screen, you can grow it on demand pretty much with zero downtime. We do understand that SaaS isn't for everyone, and there are, again, certain network limitations which just don't allow you to have it. So what we've also done is you can get, if you like, that same SaaS experience, that's literally the same software run on our cloud, and you can run it on your own hardware, in your own private clouds, wherever you like. So that is also an option, something called Elastic Cloud Enterprise. And we also have, for the Kubernetes folks, we have our own operator. So literally just apply our operator, say I want a cluster of X amount on this version, and the operator takes care of everything. And if you're not into orchestration at all, you can still, if you want to grab each individual component and run it yourself. So you can spin up Elasticsearch nodes manually or via Docker, because we do have our own Docker containers for pretty much everything as well. So there's many, many different ways. You can, if you really wanted to try it now, if you don't want to go on cloud, you can just go to our website, download a tarball of Elasticsearch and run it. It's that easy. Talking a bit about our security journey. So, how did we end up where we are today with a out-of-the-box security solution? And we're calling it security because it's not, it was previously called SIM, but we've moved beyond just having a SIM. So we're calling it Elastic Security. And just to talk a bit about our journey. So Elasticsearch was initially released to solve the search problem as an open source project back in 2010. So Elastic as a company came out in 2012. And up until then, up until I would say version 5, 6-ish, the primary reason for Elasticsearch was, as in security at least, was threat hunting. Now we had data sources which are extremely noisy, produce a ton of data. So if you think of DNS logs, DHCP, NetFlow, you name it, a ton of data that even back then, terabyte was considered a lot of data. Terabyte these days is pretty much nothing, but something that was either really expensive to put in traditional security tools, or just we need to have a secondary place to have it. And we need to put it somewhere where we could scale it quickly and search within seconds. And that is why people started using Elasticsearch. That was the pretty much the primary reason. But that's why I started using it, because I needed a fast place to search very noisy data. But then over the years, as a company, we started to realize the potential we had and how we can make our users' lives easier, especially in the security world. Like, we didn't want to be seen anymore just as that threat hunting platform where if we wanted anything a bit more than that, you'd have to roll up your sleeves and build everything manually. So I think it was about 2008 where we decided we're going to start building a solution on top of the stack. And the first version we released was in 2019. So June 2019 with version 7.2, we had a security solution as part of the stack. And then we are today with 7.9, we have endpoint as well. But what led us there was we joined forces with a company called Endgame, which had been doing full endpoint detection response, endpoint protection platforms for a few years. Perched, which was a company around providing training around threat hunting platform, I should say threat hunting on Elastic and building out Elastic as a security solution. We released our Elastic Common Schema, which was fundamental to be able to build anything. So essentially a convention for naming fields across different products. So a lot of stuff was done along the way. And here we are today with a solution which is pretty incredible, if I may say so myself. So obviously we're going to be seeing a lot of it, but there was a lot of work that led to it. It wasn't just like an overnight thing. And this session is pretty much titled this, what there's on the slide instead of programs teams, but we see it pretty much everywhere. And what we want to do is we want to be able to arm every analyst out there. We want to be able to make security available to anyone. So not just someone or an organization with a multi-million-dollar budget. No, the core of Elastic and the stack is free. There's a lot of the components which are 100% free. You can just go and run them as long as you like. And it's also built and designed by security professionals. So we have a pretty incredible research team, which is pumping out detection rules and protection strategies all the time. We have our malware detection, which is pretty much world class. So there's a lot of work going into there. And it's pretty much everywhere. Like a lot of people are using us in some way or another for security. I have many more slides left, so don't worry. I won't be rambling on for too long, but I do want to talk a bit about this slide because it shows a lot of what we're going to be talking about today visually. So instead of me going through every single point on the screen, we're going to be seeing a lot of this live, but there's a lot of thought that's been going into this, sort of all our detection strategies, how things work together, what does it mean for an analyst, how does someone follow up? So like this slide just gives, it might be a bit overwhelming, but it gives you an idea of, what someone can do at a glance, right? And sort of the workflow we have in our heads. Constantly adapting, of course, constantly adding things and making things easier, but sort of here is where we're at today with this version. There's a sneak peek into something there, so I put that emoji, but hopefully you'll be able to see sort of how powerful this is already in its current state. Let's go and dive right into a demo. Hopefully I can get through everything on time. And I like being respectful of people's time. So I'm just gonna dive right into Kibana here. There we go. Okay, so for those of you who have never seen it before, this is what Kibana looks like. And this is the latest version as of the time of this presentation. So actually I'm a minor version behind. So 7.9.3 is the latest as of today. I'm on 7.9.2. And I'm in specifically the security solution here. So one thing we did recently in more recent versions is we've made this distinction between the different solutions and the sort of the sub context inside of them. Previous users of Kibana would have noticed that there was an ever-growing list of icons on the side, which it was very hard to memorize what each of them was. So this makes it much, much easier to navigate throughout Kibana. And for the bulk of the session, we will be in the security portion. But you can see observability, like we spoke about, enterprise search, and then, of course, all the other things Kibana has to offer. So even though we have out-of-the-box solutions, you can build whatever you like. If you wanted custom dashboards, canvas workpads, maps, your own machine learning jobs, you don't have to stick to what just we provide. That's the beauty of it. You can basically build whatever you need or whatever your teams need. I'm in the overview page of security here, but I'm not going to spend too much time on it. I just wanted to just start off on this page. What I'm really going to start off from is an alert. So I'm just going to go through sort of a typical life cycle of an alert workflow. So I have a Slack bot here, which I had built. And my latest alert says, hey, we've had an alert from endpoint security. So basically, this means there was malware pretty much detected. And I built it based off of out-of-the-box functionality, so I haven't done anything fancy here in terms of customizations. The only thing which is not Elastic specific are these Slack buttons. This is a Slack feature. Massive shout out to Slack because they make security operations lives much, much easier by providing this functionality. But what I'm going to do is I'm going to dive into the alerts from here. And one thing you can do with Elastic Security in terms of the detections is provide an analyst with a link straight to that detection. And what I'm going to do is that I'm going to right click and copy this link. I'll open it up in Chrome because my default browser is Safari. So I just want to make sure it opens in this context. So let's do that. Let's paste it in here. And let's see what we have. So this is going to take me straight into that detections page. And it's going to filter for the right time range, of course, everything that I expect. And this page here is what you typically get when you click inside of a detection rule. So this one was Elastic Endpoint Security. There's all the detail related around it. So I have the query that would have triggered it, the schedule, all the about context. It's all there. I also have sort of the last time it ran, who updated it. So everything is right at the tip of my fingers. Then I also have the actual alert itself. So you can see here, it's basically saying we had malware detection on this host. Now, malware detection, this is part of our endpoint. So we have detection and prevention. I hate using the term next gen, but it's sort of doing what next gen antivirus does. It's signature-less malware protection and detection. So you'll actually find this on VirusTotal. If you upload a file to VirusTotal, Elastic is one of the engines on there. It's the same thing that's powering what the endpoint provides. And what I did in my case was I added an additional field here to show me what the file was. So there's this funny file here, b3y48 whatever.exe that was detected by our endpoint. Now, there's a couple of ways I can start dealing with this as an analyst. So you can see, because it's malware detection with a high score, it's given a high risk score of 99 as well. And this is actually taken from the endpoint itself. And you can see here, we have this concept of overrides in the data. So this was something we introduced in 7.9, where instead of having a static value, you can basically have it picked up from the raw data itself and used as part of the alerts. First thing I'm going to do is I'm going to mark this as in progress. So I've picked this up as an analyst. I'm going to mark it as such so my other colleagues don't work on it in the same way. And it's now in the in progress queue. And the first thing I'm going to do, I'm going to make this full screen. And for data coming from our endpoint, we have a specific view called Event Analyzer. Now, we are going to make this view available to other data sets as well. So we started off with the endpoint data. But you can see here this hexagon icon. If I click on it, it's basically opening up what we call the Event Analyzer, which is essentially a process tree view surrounding that bit of data. So we have the full basically process lineage around the process ID. Now, what do we have here? So what we picked up, remember, was that malware sample. And you can see here, this box highlights basically where the analyzed event was. So we have certutil, and we have two events, two file events. I actually had two of those files created. The reason there's two is because I screwed up the sample, but that's me. But we can see here, basically certutil created these two files, or this one file, I should say. But certutil seems to have been spawned from Excel, which was spawned from Outlook. So like if you start putting this flow together as an analyst, how does this typically come? Excel from Outlook, phishing, macros, malware. That's where my head is going to right now. And in fact, I can actually show you because I detonated this on a machine I have here. This is what this campaign looked like. So it's actually, this is based off of APT28, if any of you are familiar. So there was this Excel sheet which contained a ton of macros, which did a bunch of malicious stuff. So I detonated this for this presentation. And this is what we ended up with. In actual fact, the malware didn't run in full because there were some things preventing it, something else on the endpoint, but we were able to detect that malware. Now, we can see it immediately here. We know exactly what created the file, but we can also see the certutil arguments. For those of you who aren't familiar with certutil, it's basically a Windows tool which allows you to encode and decode values. So in this case, what actually happened was we have this text file here, m1 blah, 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 which was actually generated by a macro that ran in Excel, which when decoded creates that binary. So we can actually see all of that as well. We can see anything else that happened around that same lineage. So as an analyst, I saw this. Okay, that's something I'm going to want to follow up on for sure. But what I want to do is, since we clicked on that singular alert, one thing I should do is check if there are any other alerts that happened for that host. So what we can do is actually, I'll leave this for now, and I'll go to the detections page. What this allows me to do is, instead of honing in on a specific singular detection, it actually allows me to see if there were any more in that time range. Let's just 24 hours, because those are earlier today. And we can see actually there was one more alert which triggered. It was very related, which was an out-of-the-box detection we have for that sort of activity with certutil. So encoding or decoding files for a certutil. So I can see that that was picked up as well. So just to show you that obviously there's a lot to get out of the box in terms of those detections. So we were able to pick up that activity with two of the out of the box detection rules. So I know now that there's something happening on that machine. I'm just going to go back to that alert, which is still in progress. And I'm going to actually now send this to our timeline. What is a timeline? So Event Analyzer isn't the only way you can investigate this. We can send it to what we call our timeline, which is a really easy way of manipulating searches for further discovery. So by default, when I click on this investigating timeline, it's going to send this event based on that ID, so the singular alert ID. But what I might want to do is I can actually, if I wanted to, for example, grab this host and send it to the timeline. So I can see any other activity that happened around that time frame. So let's just do that. And you can see how it drags it, or I should say sends it straight to the query bar. I can manually drag this around if I want. I can take this off if I need. So I can see here now everything else that happened on that host. And you can see, even for something which isn't an alert, you have that event analyzer view. So basically any bit of telemetry that's coming in from the endpoint, you can visualize it in the same way. So as an example, if I click on this, I get the same view, probably going to be totally unrelated. It is, as you can see here. But I did want to highlight that you have that view pretty much for everything. So I did want to highlight the timeline. And what we can do as well is we can leave notes in the timeline. So I'm going to do that. I'm going to leave a note here just to say that, hey, file created via certutil seems to be phishing Excel as a parent, as an example. And these notes allow you to leave markdown syntax, so you can leave screenshots, comments, whatever you want. So I'm just going to leave that note. And you can also leave notes at a more sort of generic level. So you can leave a note at an entire timeline view if you wanted to. I'm going to give this timeline a name. Let's name it Meetup, of course. What else would we name it? And when I give it a name, and then I can do further activity with it. What I want to do now is I need to make other members of my team aware. I want to make other people aware about it, because there's stuff running on that endpoint which is potentially malicious. We should clean it up. We should take further activity. And what we have available to us is the concept of cases. So I can open up a case or an incident response, whatever you want to call it. And to do that, I'm actually going to open up the graphical view first, and then I'm going to attach this to a case. So what this allows me to do is pass this on in this current state, in its graphical state, send it to a case. So my colleague who picks it up, or my other team member, doesn't have to start from scratch. They're immediately honed in on that event. And you can see here the attach to new case button. You can also attach to an existing case if you wanted to. So let's go ahead and do that. And I'll give this a name. Again, I'm going to call it Meetup. And you can give it any tags that you want. So let's give it malware, endpoint, let's leave it at that. And again, this concept of markdown. So you can have markdown syntax pretty much anywhere. So if I want to leave additional data, additional comments, additional timelines, perhaps, I can do that as well. Let's create that case. And once I create the case, you can see here, it's now basically a place where a team can collaborate, or multiple teams can collaborate. So we pick up all the participants, the reporter, how long this has been open for, so on and so forth. What we also allow you to do is integrate with other ticketing tools. So we know most of the time people already have some form of case management tool or something that they're already using, and maybe you want to keep using that as sort of the system of record. Totally fine. So as of this version, we support 3 different external case types, which are Jira, ServiceNow, and IBM Resilient. And you can see here I have a Jira hooked up. So if I wanted to open up a Jira issue right from within here, and keep that up to date, I can just hit that button and it'll do it for me. So it's going to go in the background, open up a Jira issue, and I get a link to it here if I need. And it also keeps track of the state. So really, really simple, really easy. If I leave another comment here, it will tell me, hey, you need an update. It is singular flow for now. So it is from Kibana to the third-party tool. In the future, we will be allowing full bidirectional flow as well. So I've opened up that case. That's great. I do want to highlight some other things that an analyst can do as part of that detections workflow. So I'm just going to go back to detections. And in the last 24 hours. And I want to see what else I can do with these alerts, right? So I know this is currently being worked on, so I'll mark this as in progress. But what are these other scheduled task ones? I can assure they're pretty much totally unrelated, but I do want to take a look at them first. So let me open this up so you can see the full sort of data set here. And we have here scheduled task with the arguments, Office click to run, service monitor, right? So this looks like a false positive to me. So one thing we can do is we can add this as an exception, right? I basically don't want an alert whenever Microsoft creates a scheduled task for Office click to run service monitor. So I'm just going to copy this value with this handy little button here. And I'm going to add an exception. Really easy. We have these 3 dots here, add rule exception. And this opens up this exceptions workflow, which basically allows me to build exceptions with a ton of different logic. So I can have multiple conditions. I can actually look at value lists. So we can actually upload lists as well and use those. So in our case, once I listen to process.args is one of, since args can be an array. And I think, yeah, it was this, right? Yeah, so it shows it to me here. Oh, oops, I didn't mean to do that. Let's do it again. That's one of. We can leave a comment as well, just to keep track of why we did it. If someone leaving an exception should say why they've done it. I'll just say meetup example. And then I have 2 options here. I can close this alert, and I can also close any other alerts that match, right? Which is quite nice. Just to show you this operator here, I can have is in list, so we can upload lists through the UI and use those as sort of, if you have, let's say, a list of hosts you want to leave exclusions for, you can pretty much use those lists really, really handy. So I'm going to click these two options, add exception, and hopefully this is going to go in and close those alerts. It closed that one because the other two probably have some different arguments. If I click on this, just to show you what the exceptions look like when you add it. So we have a tab for exceptions. And you can see the exception we just added there, which is quite nice. And I can leave the comment. So it allows me to easily keep track of all this, of all these as well. So that's exceptions, really, really handy to have, really, really useful. And you can manipulate these. There's APIs behind them. You can pretty much do whatever you want or need. Excellent. So a few more things to cover in this context. So just hopping back over to detections, because so far we've only spoken about query-based ones, right? However, we do have the ability to create detections based off of the results of a machine learning job. The way machine learning works in Elastic essentially is we're modeling data over time. So as data is coming in, instead of looking for static values in logs, we're modeling it to look for suspicious behavior. So I have a very good example for you of that. And I'll just go back over the last 30 days of detections just to make it a bit easier. And I'll sort by the method. So we want to see machine learning instead of query-based. You can see now we have things like unusual DNS activity and a few others. This is the one I want to talk about. And to talk about it, I'll click on it first, because it's easier. And I have this one failing deliberately because I wanted to show you as an analyst sort of how evident it is that they have a rule that isn't working. I think that's all as important as having a rule working, being told. So in this case, it's not working because the machine learning job isn't running in the background. And you can actually see the status of that here as well. Now, since our machine learning runs in sort of batches of time, basically it's saying it's stopped, so it's not running. So I did want to talk to you a bit about and show you that as well. There's a few things in this. First of all, I'll talk a bit about what we're doing with this job. So this is one of the out-of-the-box jobs we have that is essentially modeling DNS requests over time. So we have one of our beats, which is called packet beat, which can look at DNS data and a lot of detail. Our endpoint does this as well, but there's also Zeek, Suricata. There's a plethora of different tools for DNS. But what we're doing is we're modeling the length of typical DNS subrequests for a given domain. One of the more common techniques for extracting data over DNS is to actually use a long subdomain as the data extracting. So that's sort of the activity we're looking for here. So you get all that detail if you wanted. You can also, if you did care about sort of the mathematics behind it, we don't hide that either. So if you click on this link, it'll actually show you all that detail. So we do show you everything. We're not hiding anything. But for most analysts, like they probably don't care too much about that level. If they did, they can see it anyway. Something I want to highlight on this one is the investigation guide. So we bundle in the ability to have an investigation guide, which basically allows you to create a step-by-step guide of what someone should do when investigating a particular detection. So we're not going to make the assumption that everyone knows everything. So we do give the ability to create those guides. So you can see here I have a guide which is telling me everything about this rule, but also how to use the different parts of Kibana. Maybe not everyone's familiar with Elastic Security, so I included a few GIFs in there. It just makes it really handy for someone to follow, being able to have that markdown syntax with images, so on and so forth. So really nice to have that in there. And for those of you who are interested, we started off with a Slack alert. Adding those is just by editing the root settings. So I can just go into actions and I can pretty much have my external connectors here. Really, really easy to set up as well. Just point, click, add in a payload, and you're pretty much good to go. So that's detections are pretty much a very standard workflow. How did I set up that policy? My endpoint for the malware detections and that sort of thing. So you can see this administration tab. It's there to do just that. So I have 2 endpoints active right now. So you can see that Windows one, which was involved. So this is my policy. So very, very easy. We had malware detection on. I'm collecting these Windows events. I'm collecting these Linux events. I'm collecting these macOS events. Just tick, done, set everything from here. Really, really, really simple. You can, of course, have multiple policies. You can do to your heart's content. There's no real limitation there. One thing I really like about this as well is we track in quite a bit of detail sort of what was successful and not in terms of when that agent was configured. So if anything failed, you can see basically pretty much everything we load up is listed here. So everything is explicitly checked for success or failure. So I did want to show that as well. Also really important for me to clarify, like you don't have to use our endpoint. I want to make it really abundantly clear that you can use any data you like, you can use any endpoint technology that you like. We have many integrations for the most popular ones, but this is available to you to use as of this version 100% free. So good for you to try it out. All right, so I'm going to talk about something which is now really exciting for me, and that is a new query language, which is EQL. Annabella said she loves the cat. I love him too. His name is Mouse, very ironically. So what is EQL? So for those of you who have been using Elastic for a while, or you just looked at me using it right now, you might not have noticed sort of the detection language that was being used. So I want to walk you through some changes we're making. So right now, if I want to build a detection rule, I have three choices, which is build a query based off of KQL, which is the Kibana query language, or the Lucene query syntax, machine learning, like we saw, or you can build rules based on threshold. So like, I want to see if there was a multiple count of a user happening on something, like multiple event codes on Windows. You can do that with threshold alerts. But the current query language is something like this, right? So I can do things like, it's pretty powerful. Don't get me wrong. I can do things like host name is this one, and for example, destination .ip falls within a specific subnet range, for example. So I can do stuff like that. I can keep adding, but it kind of ends there. You can't really do more sophisticated side queries, and it's been a limitation of ours for quite a while. And in 7.9, we actually introduced a new query language called EQL, which is the event query language. It's something we inherited from Endgame. Endgame had been running EQL for a pretty long time, and it was a language designed for security-specific events in mind back then. We've been working really hard to bring that to the stack, which is going to open up a whole world of possibilities. And I'm going to show you some examples of those now. So let's take a look at EQL. So in 7.9, we introduced it as experimental as an API call, right? So basically, no UI for it yet. It was an API call for people to start getting familiar with the language, for us to improve it a bit more. And I'm going to show you some examples of EQL queries. So you can run stuff like this. So you can see it's a really almost pseudocode style language. So like process or process name, and you can run queries like that. You can run queries like this, where you have sequences of events. So I want to look for something followed by something else. And you can see, again, really easy process where process name is this. I'm going to join it by this process ID. And I'm going to look for library events where the string, the DLL contains this DLL name. I can do stuff like that as well. So sequencing is really going to open up a whole world of possibilities. And a very classical example, I think, almost everyone asks me about it, like, hey, James, listen, all these detection strategies are really good, like machine learning and stuff like that, but I still want the ability to create my traditional, correlation style rules, 3 failed logins followed by success, all that stuff. And now with EQL, that is finally going to be possible. So I built that example here for you. 3 failed logins followed by a success for the same source on the same host by the same user. Just so you can see the actual data behind that. So this is the sort of raw data. This is our Discover view where you can see the actual raw events. So for once I created the user, which isn't James, it's Jimmy J. And you can see I ran on this host. I purposely, obviously, failed my login 3 times. Then I was successful. And I think there was like a 15-second or so period here. So with EQL now, we'll be able to write detection rules to look for this activity. So if we go back to our DevTools, I only have this filter because I want it to be honed in on that specific time range. But this is the actual EQL query. And this is, again, remember, this is the API call. So once it comes to the UI, you don't have to worry about JSON and all that stuff. It's not gonna, you're not gonna have to deal with all of that. But just to be able to run this query, I'm gonna run it. And there we go. And you can see how fast it is anyway. So even though we're doing sequences, we kept that Elasticsearch millisecond performance, right? So 228 milliseconds, which is, I think, very acceptable for our standards in the security world. And you can see I'm sequencing by the host name and the source IP, max span of 15 seconds. Then I'm looking for three failed authentication events by the username, and then a success. And that's it. You can see these, again, join keys appear pretty much exactly what I expected to see. Then I had 3 documents with success, and then that failed one. So this, you're now going to be able to create detections based off of EQL. For those of you who aren't aware, we have our detection rules completely public in an open repository. So you can actually go in and see everything our research team is working on, and including some of the rules which are coming up in the next release, which are EQL based. So if you go here, you'll be able to see sort of, and mixed in within here, there's some EQL rules. So really, really nice to be able to see that in there. So if anyone's interested, you can go in and check them out. You can also, of course, contribute here. I really encourage you to use this repository. We publish full library to do stuff. There's guides, everything, testing frameworks, all of that stuff. So this is the same thing we use for the rules we actually push out. I am going to give you a really, really quick sneak peek into what it's going to look like from a detections perspective. So this is what's going to look like in future release. So you can see here event correlation. So like you don't have to worry about any of that. Click event correlation and you build your EQL query. That's it. So it's going to be really, really powerful. There's some other types in there which I'm not going to talk about on this session, but EQL is pretty much almost there. So really excited about that. And the reason I'm so excited for it is because I've been using Elastic for a really long time, and this was a big limitation for me. EQL is going to open up a whole world of possibilities. Now, one more thing I'm going to talk about before I close off and pass off for Q&A is, we've seen a ton of stuff that you can do out of the box. But if you still wanted to create your own thing, you can. So like this is a custom dashboard I created, really simple, still all point and click, drag and drop. So like I want to make sure users are aware that to build your own thing, it's not a headache or a nightmare. You don't have to be a developer or a designer or anything like that. Really, really simple to build anyway. And you can see here, I put a lot of data sources on the same thing, can customize to your heart's content. Really, really powerful stuff. And one more thing I'll show is sort of that integration page. So something we're calling Fleet and the ingestion manager. So this is sort of the core of allowing our endpoint to work. So endpoint is essentially an integration on top of our Elastic agent. So there's many more integrations. So if I wanted, for example, to get data from my Apache logs, I click here. It will show me any dashboards that come out of the box with it, show me the fields, add Apache. And then, so I can either, let's say I put on a new one or an existing one, and then I can configure it like this. So really, really simple. Just put in my paths and I'm good to go. Save integration gets pushed out to the endpoints as well. So really, really nice. So I'm going to end off with a few more slides. Okay, so let's say, I did a fantastic job and you love what you saw and you want to find out more. So first of all, we have a fully open demo instance, which you can use and just see different components of Elastic and the stack, not just security, pretty much every solution we spoke about, dashboards, that sort of stuff, all there. You can, of course, try it for free for 14 days on Elastic Cloud. That's simple, no credit card needed, just go in there and you have 14 days with all the features that you just saw pretty much. And lastly, we have a fully open Slack workspace, so you can go and ask questions. There are security channels in there. I'm on there very, very often. The research team, developers, and hundreds of other community members. So you just drop in a question, and I can guarantee it will get answered in a few minutes most of the time. And since there's so many different people from different places around the globe, there's always someone looking at your questions, which is pretty, pretty cool. So just wanted to highlight that. And my last slide is saying thank you for joining. I know there's a tremendous amount of virtual content these days in the current climate that we're in. So thank you for taking the time to join us live. And even if you watch the recording, thank you as well. I know you have to selectively pick what you watch these days. We do have a feedback form, really helpful for us to make these better. So if you can just head on to that link over there. Really, really simple. And Dalia will post it in the chat as well. But it just helps us make these better every time. So please do provide feedback if you can. So that's pretty much all I wanted to present. I am going to take questions now, so we can take some live Q&A. So Ivan has asked, what is the best way to migrate rule exceptions between Kibana spaces? That is a fantastic question. So that is something that's coming up, Ivan. Just fully being able to make any object within spaces reusable, not just exceptions. So that's coming up in a future release. So hang on tight, it's going to come there very soon. What happens with exceptions, just to give you a bit of background, exceptions are added as indices in the background. So when you upload a list and add an exception, it just adds part of an index. So for us to be able to transfer it between spaces, it can be treated like any other object. So that's what will happen. Okay. Anyone else has any other questions they'd like to ask? Support integration with the Hive. You know, Jao, I get asked this question a lot. Very soon, yes. So like the Hive is definitely on our list for a native integration. We love the Hive and that project. We think they did a phenomenal job. So yes, absolutely, we'll have that in an upcoming release. Not just yet, but it will be possible. Today, if you wanted to have integration with the Hive, since we support webhooks as part of those external actions, that's what most people do until we have that natively. So just making a REST request to the Hive with their excellent APIs that they offer. So that's the way to do it, but native integration for the Hive will come, I can assure you. Any more questions? This is a safe space, okay? So there's all questions are totally valid. So feel free to ask whatever you need. That's a great question, Ivan. So Ivan just asked, have you experimented with supervised learning for detections? I haven't personally yet. So this is a bit of background context. So in Elastic, we've had for a very long time unsupervised machine learning, which is pretty much one of the examples we saw today. So basically, without user input, you go in and it will learn that typical pattern over time. A few releases ago, we added the ability to have supervised learning. You can even use your own models if you wanted to. And we actually published a blog post about this for domain generation algorithms, so DGA. So that's now part of the stack as well. I haven't personally used it yet, and we are thinking of ways of using it and using it cleverly in the stack as well. But personally, I haven't had the time. For anyone who is interested in seeing what that looks like, go ahead and read that blog post of DGA. Literally just type DGA Elastic in Google, it will come up. It's by one of my colleagues, Camilla. She did a fantastic job on it. But great question, Ivan. I just haven't had time myself personally. Any other questions?
I also put the link to our YouTube channel on the messages, so everyone can see where we upload our recording. So this recording will be available in the next few days there.
Excellent. Thanks, Daria. All right. Well, if there aren't any other questions, thank you again all for joining. We'll give you 10 minutes back. Enjoy the rest of your day. Please stay safe. And thank you again.
Thank you so much, James. Amazing presentation. Thanks everyone for joining. We look forward to having you again at our meetups, and enjoy your evening.